These maths videos. We're continuing in our videos on coordinate geometry. Here's Yoda to help out, and what we're looking at today is slope. So hopefully you'll remember something of slope from your previous studies. Let's just do a quick run through. So what's slope? Another word for slope is gradient. So if you see gradient in a question, what they're talking about is slope. And slope, as you hopefully remember, is the change in the vertical distance compared to the change in the horizontal distance. In other words, how much are we going up or down compared to how much we're going along. So if you're walking up a hill, say you're walking up the hill from Rathmines to Rathgar, it's got a very gentle slope because you're not going up very much for the distance that you're going along. It's a long road and it doesn't go up very much. Whereas if you're walking up from the hockey pitches in high school, it's quite a steep slope because you're not going very far along, but you're going up a long way. So that's what slope is. It's the change in the vertical distance over the change in the horizontal distance. For instance, like that slope up from the hockey pitch up to the school. And we also talk about it being rise over run. That's a very, very useful definition of slope as well, especially when you have a diagram, because sometimes rise over run makes more sense than the formula we're asked to use. Just a quick note about positive and negative slopes. So we always read slopes from left to right. So we start at the left-hand side of the line, the left-hand end, and we finish at the right-hand end. If we're starting on the left in this line here and finishing at the end on the right, if you notice, we're going up and along. So we're going up however many squares, up, and we're going along. So we're going up and we're going along. That's going to be a positive slope. So what looks like an uphill slope going from left to right is a positive slope. If you notice here, what we're doing is we're going down and we're going along. So we're going down and along, and that's what's called a negative slope. Always reading from left to right. So a positive slope is one that goes uphill, and a negative slope is one that goes downhill. Always reading from left to right. So what's our key ideas again? Our key ideas are change in vertical distance over change in horizontal distance. Slope is also known as rise over run, and we always read from left to right. So we have a formula which is in your tables book, which we can use for this. And the formula for slope, which we'll be using, is the formula is y2 minus y1 over x2 minus x1. And that's for the slope of the line joining 2 points. Okay, so for instance, we might have that the point A is 3, 5, and point B is 7, 12. So the slope of line AB is what we're trying to find. Okay. So what we do, as with all these, we label our points x1, y1, x2, y2. So A is point x1, y1, B is point x2, y2. We write down our formula. So slope formula is y2 minus y1 over x2 minus x1. So 7, 12 was x2, y2, and 3, 5 was x1, y1. So y2 minus y1 is 12 minus 5 over x2 minus x1 is 7 minus 3. So y2 minus y1 is 12 minus 5 over x2 minus x1, which is 7 minus 3. And remember, this line here means divide. So we have 12 minus 5 is 7, 7 minus 3 is 4. So the slope of this line is 7 over 4. So we notice it's a positive slope. We can leave it in this form. We don't have to make it into a mixed fraction. So we can leave as an improper or top-heavy fraction. And what it's saying, going back to rise over run, what it's saying is that our rise was 7 for our run being 4. So as we went from left to right, we went up 7 and along 4. Okay, so let's try some more examples. just work through these, and then in the next video we'll talk about parallel lines and perpendicular lines and so on. So let's take some more examples. So in this example we've got C is 3, 1 and D is 5, 3. Okay, so C is 3, 1 and D is 5, 3. So C is 3, 1, that's x1, y1, and we're being asked to find the slope of CD. And D is 5, 3, which is x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1. So 3 minus 1 over 5 minus 3, y2 minus y1 over x2 minus x1. 3 minus 1 over 5 minus 3, so that's 2 over 2, which is a slope of 1. So what does that mean? That's a positive slope. It means we went up 1 for every 1 we went along. Okay, up 1 for every 1 we went along. Okay, what would that look like? That would look a bit like that line there. Okay, if you can notice, for every 1 we go up, we're going along 1 as well. So up 1, along 1, up 1, along 1, up 1, along 1. Okay, what's the next example? Let's take some negatives this time. So let's say F is minus 1, 2 and G is 3, minus 4. We're trying to find the slope of FG. So F is minus 1, 2, x1, y1, and G is 3, minus 4, x2, y2. So the slope equals y2 minus y1 over x2 minus x1. So that's minus 4 minus 2 over 3 minus 1. So it's minus 6 over 4. Now if we have a slope like this that we can simplify, if you put that into your calculator, it'll reduce to minus 3 over 2. So the slope of FG is minus 3 over 2. So what does that slope look like? Well, let's say here we've got F minus 3 over 2. It means we go down 3, 1, 2, 3 for every 2 we go along. So that slope looks like that. We go down 3. Okay, so down 3 for every 2 we go along. And that's a negative slope. Okay, let's try one last one with loads of negatives this time. As many negatives as we can. Okay, let's see. So, example. W is minus 5 minus 10. And Z is minus 9 minus 3. Find slope WZ. So W is minus 5 minus 10. That's x1, y1. And Z is minus 9 minus 3. That's x2, y2. So the slope is going to be y2 minus y1 over x2 minus x1, which equals minus 3 minus minus 10 over minus 9 minus minus 5. So minus 3 minus minus 10 is minus 3 plus 10. Minus 9 minus minus 5 is minus 9 plus 5. So that's going to equal 7 over minus 4. 7 over minus 4. So it's got a slope of 7 over minus 4. So what does that look like? And that's the slope of WZ. What does that look like? Well, say we've got W here and Z. It's actually quite hard to draw a slope that's 7 over minus 4. It's actually easier probably going from left to right to draw a slope of minus 7 over 4 rather than 7 over minus 4. And they're the same slopes. So minus 7 over 4 means we go down 7, 1, 2, 3, 4, 5, 6, 7, along 4, 1, 2, 3, 4, and we end up here. So you notice actually it's not that different to the previous slope. In our other example, it almost looks like it's parallel, but it's not actually. It's slightly off. but it does look like it's parallel. Maybe if I extended them both, we'd see that actually they're not parallel. Here we go. Let's extend this up a bit, and let's extend this one down a bit. They do look very parallel, don't they? But they're not. Now, you know, I said this was an easier slope. Minus 7 over 4 was easier to draw than 7 over minus 4. To draw a slope of 7 over minus 4, we would have to probably start at z actually and go from right to left. So 1, 2, 3, 4, 5, 6, 7, and minus 4 along 1, 2, 3, 4. Or 1, 2, 3, 4, 5, 6, 7, and 4 along 1, 2, 3, 4. So that's why it's easier sometimes to draw minus 7 over 4 rather than 7 over minus 4.